Hello, 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 Aiken. How we doing? Let me switch to the other cam. See how this is looking here. Hey, alright, there we go. There we go. Hello, hello, hello. Hope we're doing fantastic. That's what I'm hoping anyway. Are you doing well, Aiken? I hope things are going very well for you, my friend. Absolutely well. Let us see. Let us make adjustments. Yes. I think that works? Question mark. Guess we'll have to roll. There we go, there we go, there we go. Hey, there's Riv Spice. How you doing? The professor is in. Yes, yes, he is. If you want to call me a professor, that's fine. I'm still not sure about the title even to this day, but it's a thing, so it works. I was like, magic happened. They gave me some degree. I could call myself some random professor thingy thing. Bro, what a day yesterday. The doc. No, I'm definitely not a doctor, I can tell you that. I got PhD in nothing. I have a master's degree. Oh, a master's of something? I don't know. Oh, man. I'm about as much of a doctor as like Dr. Lupo or Dr. Disrespect or whatever. You're about to start your CS curriculum at DePaul and half excited and half anxious. Well, that's very good to hear. I am excited for you as well. Most anxious by it's gonna take it's a bit of work. Okay, so you probably already know this, but I'll restate it again. Most of the work in computer science is going to be debugging and looking through piles and piles of code and correcting it, and kind of doing that sort of thing. So that's how my CS degree kind of went to. Was spending many hours just trying to make sure I can debug everything. But yeah, once you kind of start getting more comfortable with that, then at that idea, then I think it'll reduce the amount of anxiety that you'll have there. Inevitably, that's just going to be the workload that you're going to have. But if you're going to have fun, thing I would have to say is just have fun with it. It's not fun to sit in the same place for hours and hours on end, but have a lot of fun with it, and I know that it's going to go really well for you. That's the attitude that I took it. Yeah, you know what? That's what it is. Yeah, exactly. If there's an innate love and interest in working for you working through that stuff, trust me, you're gonna find it really fun and exciting to go through debugging and maybe just trying to refine and perfect your code into doing what you want it to do. Nice part about coding is there's always room for improvement because there's always new techniques that you can certainly learn along the way. And that's what makes it pretty fun. That's what makes it kind of nice, actually. So, with maths, I think it's fair to say. So, with math, it's fair to say that math is a subject that's been around for a very long time. You're talking 5 millennia or longer. Okay, so math in some form of construct has been along, in a very large capacity for a very long time. In fact, moving the needle for math typically doesn't revolve around moving the needle in large quantities in a direction. Instead, it involves moving the needle in very, very tiny incremental uh, things instead. Um, Math is a bit boundless because sometimes we see things, or again, we construct things in order to quantify something, maybe in a new way where we can apply it to something else, maybe in another field later on. So if we find the way of how our construction of how we can quantify things work, yeah, you could say that things are boundless, but those things are going to come in very small increments, little by little, since you're dealing with probably the oldest field of science um, uh, humanity currently has. So I would say one of the oldest fields, actually. You can make an argument that astronomy is probably one of the ones that are up there too. We put that in there. Take some supplemental tingly. There we go. Math is a fun subject like that, I suppose. Again, with its countless applications to pretty much everything, you know, you can never go wrong in learning the fundamentals behind the things that people see every day. Nothing wrong with that whatsoever. Oh man, ready for another rip roaring day? God, hey, Labor Day weekend is on Monday. There you go. Labor Day weekend. So that is what's on the docket here. Or it's not too bad. Did I have a hand up? Check that. I do not remember. Oh, I do. Okay. All right, I can do that for next go. No big deal. Touchdown. All right. Alrighty, we're gonna wait for just another minute or so, and then we'll move. We'll move forward after that. Yeah. That's fine. All right. No. Hey, good morning, Jasmine. How we doing? What's this? What class is this for? This is for statistics. River Spice. Class is for stats. Uh, how we doing today, Jasmine? How we doing this morning? Good morning, Isabella. How we doing this morning? Hopefully doing absolutely fantastic. Hey, don't worry about it, my man. You're all good. You're free to interrupt whenever. Okay. You need to ask me a question. And he says, "Hey, I'm just curious. I want to know." I'll be more than happy to answer that question for you. No problemo. Good. Doing great. How was last night? The arena was lit. Oh man, I had so much fun. In fact, I'm doing a lot of fun. Even if I have this shirt on here, I'll zoom back here myself. So I bought the let me stand up here for a second. I bought this CM Punk shirt yesterday. Best in the world. There you go. Yo, the only place you can get this shirt is at the show because you can't even find this online. It is lit. Now this shirt is really comfortable too. So I love it. This shirt is amazing. And I got to see CM Punk in person at the show. Um, standing in the ring. Oh man, for a first ever wrestling show, you get to see CM Punk. That's pretty awesome. And it was good to see. You wanted to go so bad, but they sold out ASAP. Well, the Dynamite show was yesterday, so I didn't think that was sold out. There were tickets available up until showtime. But if you wanted to go to All Out, which is this weekend, the pay-per-view, yeah, that's sold out. The prices for those tickets are pretty expensive. So, oh yeah, if it was all out, yeah, you're not gonna find tickets for that unless you're on the resale market. So, that's why I opted to go to Dynamite, because the tickets for all out were so. I'm like, $150? Like, oh my god! I thought that was expensive for me. So, and then some people were like reselling them for like 7 times the cost. Crazy. Guy that I knew bought a couple of tickets for $100 each, and then resold them for 700. It's just like, that's great. Absolutely bananas. I saw CM Punk's stream rules a while back against. That's ironic you say that, Joseph. It's ironic you say that because CM Punk was at the show, and then later on, Chris Jericho comes out and starts talking his promo against his match against MJF. So you actually saw both of them. It's ironic you say that because you talk about a WWE pay-per-view, and then all these years later, CM Punk and Chris Jericho are at the same show for a different company. It's a different wrestling world out there than it used to be a long time ago. I'm not gonna lie. But one thing I can say for sure, and I think you'd agree with me, Joseph, it is good to see both of those guys back in the ring and having a wonderful fun time. All right, ladies and gentlemen. All right, let's go ahead and get started. We'll do the intro. We'll get going here, and then we'll start with some stuff. Sure, why not? I think that'll be fine. Woohoo! All right. Let's do this, ladies and gentlemen. Okay, go ahead and do this. All right. Okay, let's get started today. Welcome back to Thursday, end of the week time today. So today, everybody, we are going to be moving forward here with the textbook. All right, last time we finished up most of Chapter 2, actually all of Chapter 2. We talked about arranging graphs, we talked about arranging graphs and data, looked at histograms, the whole 9 yards here. Stuff that wasn't so hard. It was pretty relatively straightforward. I think you guys had a nice, easy time with it. All right, easy peasy lemon squeezy. Today, hopefully, today will be also just as easy. Nice, a little bit easy peasy lemon squeezy as well. Things that you probably have heard about many a times before. So hopefully, this will not be too bad of a thing today when it comes to getting a few more results from our grouped up data that we'll talk about here in Chapter 3. All right, so we're going to start here with Chapter 3. And so, like I said, but we're going to be introducing a few new things, at least even with simple concepts. We'll talk about a few things. So we'll certainly reflect on that. All right. Let's look at the big board here. All right. So this is from the handout here for 2.3.2.4.3.1.3.2. We're going to start in section 3.1. All right, so this is something that you probably have seen before in some capacity, but let's talk about it here today. Let's talk about mean, median, and mode. I think most of you have seen mean, median, mode in some capacity. Has anybody not heard of mean? I hope so. Hope you have. All right, in any case, if we talk about mean, median, and mode here, let's discuss it from a simple point of view. All right, we're going to do some examples here, and then I need to show off here some important things. All right. So first of all, number 2, how do we find mean? All right. So mean here in terms of words, I think most people are fairly comfortable with the idea of mean. So in terms of just words here, mean is going to be, again, the sum of all the data items. Actually, I should say, yeah, the sum of all the data items. Sorry, I've got that almost backwards in my head. The sum of all the data items divided by the number of data items. Okay, so in terms of a word definition here, this is what mean represents. Now, the next thing I'm going to talk about here is going to be setting us up for a lot. Certain things I do in this class for a particular reason. This is one of those things that I do for a particular reason. Is if you're referencing the textbook or you're referencing the homework, sometimes this is going to be section 3.1 here, Jasmine. All right. So section 3.1. So sometimes here, what we talk about is we want to talk about notation. Okay. And notation here is going to be incredibly important because you're going to see that notation on the homework, or you'll see that notation as I write it down here during lectures. So this mean, as terms of a concept, you've heard many a times. You talk about average and stuff. So probably as a concept, since you've probably done it, way back in the day, this shouldn't be anything that should be any brand new. However, the notation here I'm going to be showing off as well. So oftentimes what you'll see me here in questions, you'll see me actually put in the words and what they represent and the notation to go along with those words. Okay, so that way you see both and you'll know what they represent at the end of the day. And you will, again, certain things that you'll see along the way, I'll just be using notation for and then explaining in words as well. All right. So what's the mean here in terms of notation? Let's talk about that. Now the mean has some different notations here, and I will need to actually bust out my math type program here for this. So math type's gonna certainly be a thing. Sure that this goes off. All right. So the way it's gonna work like this. Let's talk about this here. First and foremost here is going to be this this dude right here. So this is what you're gonna see. You're gonna see this guy here, X bar. All right. So for your notes here, X bar is going to represent mean. All right. So this will represent mean at the end of the day. Let me actually put it as text there. All right. So actually, you know what? I'm going to actually put this in a slightly different form. I'll put this as sample mean. Let's put it as a sample mean. I'll put it over there. So, so X bar here will be in sample mean. All right. So if you see this notation, if you see this notation when you're trying to get help with a particular problem, that's what this will represent at the end of the day. Now, if I'm going to write out the formula here for mean, we're going to need to go over some other pieces of notation here that are just as equally as important. The next piece of notation here that I'm going to discuss is this piece of notation. Find that guy. Find that guy here is actually tough. There you are. All right. All right, so the next piece of notation that you're going to see here is this dude, which is sigma. And this sigma here represents the sum of all. Okay, so if you see here in the sigma, this sigma here represents the sum of all something. All right, so we're going to fill in the blanks here. You'll see what that represents, but the sum of all. All right, so that's what we have here in this case. All right. If we talk about data items in particular, all right, data items will be just represented by X. Okay, so if we just represent it by X, I'll show you what I'm actually putting on the screen here. Okay. literally putting this on the screen. Hey, thanks. Thanks, Daikon. I really appreciate that. We're doing some statistics here. So X here is going to be the data item. Data item or data items. Okay. Actually, I should probably also put XI. There could be multiple data items. Right. Copy and paste that. Bye-bye. Oh, that wasn't. Hey, got a second? It's always copy paste. I think you do it the first time and it doesn't. All right. And then the last thing I kind of want to talk about is the number of data items itself. So if we talk about the number of data items, we typically, in the sample, we typically say the letter N here is typically our notation for this. So what I'm basically saying here is you're going to see this quite often here in a lot of these formulas for this, for a lot of formulas that we'll see here in the course. All right, so let's go ahead and put that down. All right, so the number of data items sample. Right. Let's go ahead and copy pasta this. So copy pasta. All right, there we go. Okay, so if we're putting this formula here together for mean, and like I said, mean here as a formula isn't like super duper hard. That's not the point. The point is to get you more comfortable with the notation here for what you're going to be seeing later on in other sections and whatnot. So I don't want you to be surprised and be like, oh my god, this came from nowhere. What do these symbols mean? They just don't mean, they mean gobbledygook to me. I'd be like, no, they actually have I promise you, they actually have a representation. They mean exactly what they intended to be. So let's go ahead and put this down. So I'll do this. I'll do this, and we'll do this. 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 All right. So as a formula, this is what it looks like. Here you go. There it is. In terms of it's a short, simple, notational wise, this is what it looks like. All right. Any questions? Any questions about that so far? Any questions? We'll look at an example here in just a second. But again, if you have questions, please type out your question. If you don't have questions, type no in the chat. I'll move forward. Simple as that, folks. Okay. Yeah, notation's going to be kind of like, honestly speaking, notation's going to be kind of like a big thing in the course. So I just want to be sure that you guys are taken care of and know exactly how to do these things. Oh my god. Okay. All right, so let's go ahead and do an example here. Let's bust out a paint tool. Let's get out paint. Bust out the paint tool here. Let's do some examples. Let's see what we get. Why not? Easy peasy lemon squeezy. Okay. So let's put in an example here. I really like that. It's terrible. Oh, that's why. Okay. Let's put an example here. Let's make up some numbers here like we did here last time. And let's find out how we can go ahead and do that. All right. Seems pretty reasonable. Wonder how I want to do this here. Okay. I think I know how I want to do this. All right. So let's set up a stem and leaf plot here. So I'm going to set up a stem and leaf plot for our example. All right. So I'm going to make up some random numbers. And just going to see what we come up with. 0, 0, 2, 6, and 7. 2, 3, 5, 8, 9. Okay. 4. Okay. So, this is what we've come up with. All right. Nothing too fancy, nothing too crazy. There it is. Easy enough. All right. Seems pretty reasonable. Okay. Why is that? Yeah, I turned that. Here we go. Okay. All right. So, basically the way to read this is 0, 3 would represent the number 3. Okay, so even though it starts with 0, you would say 0, 3. That represents the number 3. 0, 7 represents 7. 1, 0, just like we talked about stem and leaves, 1, 0 would represent the number 10. All right. 1, 2, 12, and you get the general gist. That's pretty much how that's going to go. All right, so if we talk about mean here, all right, if we talk about mean, we'll put X bar here just to showcase the notation. All right, all we're going to do is we're going to add up all these numbers together and then go ahead and divide by how many numbers that we have here in our sample. All right, so in this instance, we're going to take, again, if we're just manually doing this out, 3 plus 7 plus 10 plus 12 plus 16 plus 17 plus 23 plus 25 plus 28 plus 29. We'll just keep going down the line here. 31, 34, 40, and 48. And we're going to divide all that by, let's see how many numbers here we have. We have 2, 6, 10. Like we have 14 numbers. All right. Now, I would like you guys go out. Okay, I would like you guys to go out to 4 decimal places if necessary. Can anybody tell me here what the mean for this data set is going to be? What is the mean for this data set? Anybody got a result for me here? Again, 23.0714. Okay, cool. All right, excellent. All right, we're gonna put that in our back pocket here, and there you go. That's gonna be our mean. I think everybody knows pretty much how to do this. Really, the notation here is probably the more important part in this situation. Okay, so that's about mean. Great, no problemo, easy peasy lemon squeeze. Whoa, Venom! Hey, Venom, thank you for the sub, man. Thank you for subbing with Prime. Hey, man, thank you. Wow, I really appreciate it. That's really kind of you. Thank you for coming on to this stream, and thank you for wanting to learn, and thank you for believing in this scrub. All right, I really appreciate it. Thank you. That's really super kind of you, my friend. All right. And much love to you, Venom. Much love. Okay. So let's take a look here at the next question here, because we have our mean here. The next one we're going to talk about is median. Now, median here, of course, we're pretty familiar with. You're probably familiar with the idea of median. However, we're just going to approach this. We're going to approach this the same way in this case. Now, there's no notation here for median. Unlike mean, median, pretty much the notation for median is just median. Okay, there's not any notation to go along with it. But let's remind ourselves about how to find median here in any given data set. So before you start to find median, doesn't matter. the first thing that you have to do before you find median is you always, remember important, and I'll put this as important here. You always order the data set before you find the median. You always put it in, say, numerical order. You always want to put it in numerical order before you do anything to find that median. If you do it out of order, you ain't going to get the right answer. That's how it's going to be. All right. Okay. Now, the next part here was once you put it all in numerical order. Now, for the purposes of our example here, I went ahead and already put it in numerical order. So we're already set and ready to go in terms of how we're going to approach this. I put this little stem and leaf plot here in numerical order, so we're fine. Now, the next thing that we're going to do is, not going to find the median just yet. The next thing that we have to ask ourselves is where the median is located. So that means that it says, all right, what's the position of the median? All right, where are we exactly going to find the median? Well, people say it's smack dab in the middle. Well, can you tell me where the middle is? You know, anybody could say it's in the middle, but where's the middle? Let's say you had a string of 100 numbers, okay? Where exactly is the middle in this case? Well, it's not exactly where you think it is, all right? So you'd be like 100 numbers, I'd be like 50 is right smack dab in the middle. Be like, not exactly for median. That's not how it works. Let's talk about what the position of the median is. All right, so I'm going to type this out here. Okay, so it's here. So that's why I always go through this question here first. The position of the median here is pretty vital. Just a second. This. Okay, there we go. All right, and this is going to use some of our previous thing here. So let's do that. Previous notation. All right, so the first thing we're going to do here is we're going to talk about the position of the median. The position of the median here is the again the sample size n plus 1 over 2. So this n here is representative of the sample size here in our data set. All right, so just the same n that we have up here, the number of data items in the sample. All right, that is what we have here in this case. Change that. Hey, Tim. There we go. All right, so you have the position of the median here, n plus 1 over 2. Now, having said that, we're going to run into two different unique scenarios. All right, so let's talk about those two scenarios here because it does actually matter here about how we're going to attack and find the median here, depending on what little n, the number of data items in our data set, is going to be. So let's take a look here and take a look at our two scenarios. All right, two scenarios. All right, first and foremost here, the first scenario is if n is even. So, and why don't you cooperate with me? Cooperate, please. All right, there you go. All right. If n is even. Actually, no, let's go with n is odd. So if n is odd, so if we have an odd number of data items in the data set, then the median can be found at exactly the position that you find it at. So the median, so if n is odd, so let's say it's like 13 data items in the data set. Well, underneath this, you'd say, okay, if you have 13 data items in the data set, you'd do 13 plus 1, which is 14, divided by 2, which is 7. So you'd find the median in exactly that 7th position in the data set. So it would be no problem for you to find it. It would be exactly where you found it, exactly at the position that you find it at. All right. So that's the first scenario. Now, what about the second scenario? Let's talk about that, because the second scenario is a scenario. Thank you very much for the follow, madam. Appreciate that. Now, what's the second scenario here? The second scenario here is if n is even. So let's say if n is even, then the median is going to be the mean of the two numbers around the position found. Okay, so if n is even, all right. So let's talk about that here. We have n is odd, n is even. All right. So if n is even, then the median is going to be the mean of the two numbers around the position found. Let's talk about that here in this situation. All right, let's go back to our example here for just a moment. Okay, and let's see exactly what we're working with. Okay. So back here. All right. So taking a good look at this here, here's our stem and leaf plot. Here's our data set. Now, let's first try to find the position of our median. All right, let's find the position of our median here. All right, so how many data items are in the data set? Can anybody tell me how many numbers do we have in the data set again? 14, right? Okay. So 14 is correct. All right, so we're going to go ahead and put in 14 plus 1 divided by 2. So if we do 14 plus 1 divided by 2, that's going to be 15 over 2. And so in reality, the position of where our median is located is 7.5. Okay, the 7.5 position. All right. So this is what we're going to do. Let's go ahead and take a look at this here. We'll mark it in red. So we're going to count 7.5 positions on our data set. Let's go ahead and do that. Okay. So let's count 1, 2, 3, 4, 5, 6, 7. So 7.5 would be pretty much right after this number right here of 17. Oh, that, sorry. All right. So this is where it would be. Okay. Now, in reality, this is why we have to do this. In reality, I think it's practical to say, hey, you know what? There is no number in the 7.5 position. That doesn't make any sense. And for me to tell you, I totally agree with you. It makes absolutely no sense that there is no number here in the 7.5 position. All right, totally agree 100%. So if we're trying to find the median here, we're going to take the two numbers around where this arrow is located. So I'm going to mark this in blue here. So I'm going to take this number here, this guy here. I'm going to take this number here as well. These are the two numbers that are around that position that would indicate where our median is located. All right. So our median here in this case where did I mark it here? Let me check again. Sorry. Back a second. Let me count. 1, 2, 3, 4, 5, 6, 7. Oh, you're correct, Alex. Thank you. That's actually right. I accidentally marked 6.5. Thank you. So my marker should be right here. There we go. Thank you for pointing that out. I almost messed up. See, you guys are here to correct me. That's fine. Let's go ahead and mark these two numbers here. I'll put it in a little boxy box thing. There you go. All right. So let's put down our median here. Oof. Sorry about that. Still going to do the same thing. So our median here, again, if I do something wrong, guys, just feel free to correct me. I have no problem with that. Remember, we're here to learn. And I want to make sure that you guys are taken care of as best as possible. All right. So our median here is going to be 23 plus 25. And then we're just going to divide that by 2. That's going to be the mean around those two numbers here. And so if we do that appropriately, then our final result here for our median is going to be straight up 24. Okay? So 24 is going to be the median of our data set. All right, so first find the position. Remember, 7.5 is not the median. That's just where you can find the median. And then in this case here, because that happens to be in a non-existent place, we take the mean around those two numbers, and then that's going to be our actual median for our data set at the end of the day. Okay, any questions about that? Hopefully that was pretty cool. Pretty easy. Easy peasy and lemon squeezy. No? All right. Again, feel free to ask me questions at any time, okay? All right. So that's about median there. That isn't too bad. Okay. Let's take a good look here. Let's take a good look here at number 4. Let's talk about the idea of median and median. Now, admittingly, you probably have heard both in some kind of random context, okay? Whether it be the average of something or whether it be the median of something. Now, in reality, in statistics, which one is usually better for many things? What is better here in a data set is actually median over mean. The median is actually better to use over average. Let's describe why that is. So why is median actually better than mean if you're actually going to evaluate a data set? Well, let's take a certain scenario here, all right? So let's take a certain scenario. I'll write this scenario down on the paint tool. It's a temporary thing. So let's say, guys, that I have 3 houses, okay? Let's say I have 3 houses. Let's say each house has a particular value in this neighborhood. All right, so I have house number 1, I got a house number 2, and I got a house number 3. So here's house 1, house 2, house 3. Okay, so let's say, for example here, that the first house is, pretty run down, needs a lot of repairs and stuff, and that first house here is worth $10,000. Okay, really just like rotting wood and needs a big fixer-upper, so it's not worth a lot of money, and you need to reinvest a lot of money to get it back into working shape. Let's say the next house is just a small upgrade over the first house. Maybe it's it's in slightly nicer condition, but still a very large fixer-upper, and it's worth like $20,000. Okay, so let's say that's worth $20,000. All right. And let's say the last house was a brand new, newly built house, okay? Super new, super fancy, super big. Let's say that is a cool $1 million. Okay? So let's say that's a cool $1 million. All right, so there we got a $10,000 house, we have a $20,000 house, and we have a $1 million house, all in the same neighborhood, just these 3 houses. Now, let's take a look at the difference here between mean and median. If I were to take a look at the property value average of this neighborhood, what I would do is I would take the $10,000 plus the $20,000 plus the $1 million and then divide that by 3, since there are only 3 houses here in the neighborhood. So, having said that, then basically I'm going to get an average of, say, $333, a little over $333,000 per house. Okay, that would be the mean value of the houses in the neighborhood. However, take a look at the neighborhood. 2 out of the 3 houses are definitely not worth $333,000. That doesn't make any sense, okay, to say that the mean is reflective of the majority of the neighborhood. All right, so average is not a very good indicator about the majority of the neighborhood here in this example. All right, but if I took a look at median, and I looked at median, and these are all in numerical order in terms of their property value. Well, the median here in this case is the $20,000 house. And is the $20,000 house more reflective of the majority of the neighborhood? The answer is yes. That is a lot easier to look at and a lot more reflective of the neighborhood than, say, $333,000, which is the average price of every house in the neighborhood. So that is why, in this case here, that we don't have really super extreme values really affected the data set when we look at the median compared to the mean. So we could say here median is more resistant to extreme values than the mean. So if we talk about it in a practical setting, this is, the neighborhood was a small example, but talk about it in a practical setting. The more important thing is if you're doing research on a job, right, and you want to negotiate a better salary, well, what you want to look at is you don't want to look at the average salary of that job. You want to look at the median salary of that job. Because at the end of the day, you want to see exactly what people are getting at the middle of the road. Because again, people could have super senior positions in that particular field, and then they're going to be making, maybe high, close to 6 figures or high 6 figures, whatever that field is going to be. So you may not be wanting to get into that particular position, or maybe you're just starting out. So that's not going to be a realistic expectation for you to get right out of the gate if you're just starting out, for example. So you want to look at the median salary. It says, okay, most people are getting this salary, to start out in my field, so maybe I should be looking at that salary instead. So that is something to keep in mind when using it in a practical setting. That could affect you, as you keep moving forward in your professional life. That is. So something to think about here when you talk about mean and median is I don't look at this. I don't want to consider the CEO's salary or a high management salary. I need to look at everybody and then seeing what exactly is in the middle. So a little bit better for a more realistic outlook. All right, any questions about that? Hopefully that's pretty simple. Hopefully that's pretty easy. Any questions before we move forward? Good, good. Good to see you, Gomesh. No? No questions? At least I don't think so. Okay. Again, type no in the chat if you don't have any questions. So that way it'll allow me to move forward. So I need you guys to type no, because then I'd be like, okay. Because if you do have questions and I'm like, I stop for reasons. So that way it's like, want to be sure that you guys get stuff down. All right. We'll go ahead and move forward then. All right, let's look at the next one here. All right, so let's look at number 5. All right, so number 5 talks about how do we find mode. All right, mode, let's talk about the definition of mode here. Mode, first of all, is the data item or items that occur the most often in the data set. There are certain rules to finding mode here in a data set. So let's talk about those rules here that are that are pretty important. The first rule here, when we talk about mode, I'll even put this on the next page down. That way you guys can see this all at once. All right, so the rules here for mode are going to be pretty simple. The first one here that we talk about is the mode must occur more than once in the data set. Okay, so the data item, all right, the data item, let's say the data item is, it has to occur more than one time. So it can't just occur once and then be considered a mode. That's not how it works. So it has to occur like 2 times, 3 times, 4 times, however many times. But again, it has to occur more than once in the data. More than once, it's disqualified from being a mode. Okay, so just want to point that out there. That is definitely not a mode if it only occurs just one time. Now, this also has a couple other implications. There can be multiple modes. Okay, so it's entirely possible to have multiple modes. So let's say you had 2 numbers occur 2 times in the data set, and that happened to be the numbers that occurred the most amount of times. Well, then you can have 2 modes in a data set. Certainly possible. That's really not too much of an issue. So it's not just always one number. It could be multiple numbers. Could be 2 numbers, 3 numbers. Again, whatever the case may be. On the flip side as well is it is possible to have no mode. So you may get a data set here that may have absolutely no mode associated with it. Okay, where each value only occurs once, and guess what? There's just no mode to go with the data set whatsoever. So that's just pretty much how it rolls. Okay, no problem. All right, so these are some rules that we certainly can follow here when it comes to mode, and the possibilities that we can arise when we're just trying to find it. Now let's go back to our example here for just a moment. All right, so let's look at our data set, our stem and leaf plot here that we have on screen. All right, and if I were to ask you here, let me make this a bit bigger here. If I were to ask you here, what is the mode of this data set? So if I ask you here, what is the mode? Change the color. I'll change it to green. All right. Anybody tell me here, what's the mode of this data set? There is no mode. Okay. Very good. All right. So good. You guys suss that out. None of the numbers here in my example repeat. So indeed, there is no mode. All right, and that's exactly how you would answer that question. Perfect. Nice job, everybody. All right, excellent. Okay, easy peasy lemon squeezy. No problemo. Seems pretty reasonable. All right. Okay. All right. So that's not too hard. Now, let's take a look here at... All right. Let's look at the next one here. Okay. Now, the next one here is talking about range. Okay. Range is probably, in this case, how do we find range? Range is probably the absolute most boring question that you can find here in this class. I'm just going to talk about it. Range is really super boring. All you have to do, ladies and gentlemen, is you take the highest data item and then you subtract it from the lowest data item, and then there you go. That's range there. That's okay, my friend. I'm just glad you're able to make it. No problem. Stuck with the class? Well, you can easily watch the replay of what you missed. That'll be right here, right after I'm done with my stream. So you can watch the video replay of anything that you missed. So underneath the videos tab there. All right. All right, so that's the range here. The range is extremely boring. Take the highest data item, subtract it from the lowest data item. Yay, that's a range. No, it's not more complicated. No, it's not something I care about significantly. But we're going to take a look at range here from a simple perspective. Our highest data item here is 48, and we subtract it by 3. And so we get 45. And there we go. That's it. Simple. Yeah. Woohoo. All right. That wasn't so super hard. Okay. All right. Any questions so far? Any questions about that? That is, I know that's not super exciting. It's not supposed to be super exciting. All right. All right. It's not so bad. Alrighty. Okay. Let's take a good look here at the next question. Now, if there's something that's brand new here that you probably haven't seen, are probably the next few bits of questions here. So let's talk about those. Those are going to be kind of the most important things here that we're going to be discussing here. So people have talked about mean, median, mode. There ain't anything brand new about mean, median, mode. Let's not kid ourselves. All right, we know about mean, median, mode. The next few questions there talk about. I'm going to talk about number 7, 8, and 9 here, which talks about population and sample variance, and then talks about the sample standard deviation and population standard deviation. All right. So for the purposes of this example here, what I'm going to do is I'm going to go in order here, just for a quick moment. I'm going to talk about population variance in terms of a formula. We'll talk about sample variance and the sample standard deviation, population standard deviation. Okay, so first of all, I'm just going to write down the formulas for number 7 and 8, and then I'm going to do number 9, and then it'll help explain 7 and 8 in a little bit of more context here. So population variance here, at least in terms of notation. Let's talk about notation here. Notation here for population variance is going to look like this. It's going to be, I need to write that down. It's going to be rows, find that letter. There you are. So the notation here is going to be this guy right here, this row squared, okay? So this is the notation here for population variance. If we want to talk about sample variance, like I said, I'll write down some formulas here shortly, but I'll need to describe what standard deviation, that stuff's going to be. Well. Notation for sample variance, let's talk about that. Notation is going to be labeled as S squared. So that is the notation here for sample variance. So you're going to see these two guys pretty often in terms of notation here. So if we talk about variance, you'll see this row squared, you see this S squared. Okay, and there you go. That's what we have. Now, why is this important here? Well, let me explain why. Well, what is the formula here for population variance? Well, let's go ahead and write that out. Oh, I don't want that. I would like this, please. Yes, sir. All right. Now, what I'm going to write down here next is going to seem a little bit confusing. Again, the way it looks like here. So I'm going to go over this very carefully. Again, some more notation here that we certainly have to acknowledge. So again, a lot of today is like an information dump based on notation, because we're going to see a lot of this same notation here later on in the semester. So I'm gonna write it out here, and then we'll just talk. We'll talk about it, and we'll discuss what that's all about. Just a few seconds here to go ahead and met that out. Okay. Describe this in words as well. Just give me a little time here. Okay. Change this. Change this to this. All right. All right, let's talk. Actually, I'll need to put this on the next page after. I just need more space to hopefully have you guys see this. All right. Let's talk about the notation here for every single one. It's every single thing we see here. These are parts of notation that you will see, again, quite often. So let's talk about them in a little bit greater detail. Look at that here. All right, so first and foremost here, what is X? X is going to be, once again here, the data item. All right, so we have the data item. Next, what we have here is mu. Okay, so that's what we call the letter mu. So mu here is going to be representative of. Mu is representative of. Sorry, guys. Is going to be the population mean. And then capital N that you see there, that capital N that you see there, is going to represent the population size, so the population size here. You put that down. Exactly what each of those mean. That sigma there that we have from before is exactly what the sigma was from before. Again, the sum of. But again, these three things are things that you certainly will see quite often in the book. You'll see the weird part is that they interchange a lot. So I want you to understand the perspective of what each of these represent, because it does matter here. As you can see, as you can see on the sample variance. So I'll go through these carefully here in just a second. But yep, got that. All right. So let's take a good look here at both of these formulas for just a moment. Okay. And hopefully this will start to make a little bit more sense about why I'm kind of presenting it this way to you. Okay. Yeah, I didn't. So that's kind of like. So that's a very that's a very good question, Vanabla. Well, there's no subscript on the I. Yeah, it's kind of weird. Sometimes they'll put the subscript XI. You could say X here is the data item because each one is individual. So you could have the XI there. You could just have the X there. Yeah, you could say that for either case. So I just put X as like the data item, and then I just distinguish that from X bar, which is the actual mean here in this case. So sometimes they'll put XI to represent the data item. Sometimes they'll just put X. So I just want to kind of showcase both. It's kind of weird how notation kind of works here in this case. So yes, that is correct, Vanabla. They are individual data items. Correct. Yes, you are correct about that. 100%. So Now, I want you to take a look at the difference, though, between question 7 and question 8 that you see on the screen. Notice that you have this mu here. Mu here represents population mean, okay? So you'll be working over two different contexts at times. You'll have population mean and you'll have sample mean. Remember, those are two different things, okay? Population mean talks about, again, the whole big group of people, whereas sample is a subset of the population. All right, so hence why mu is the population mean. However, x bar is the sample mean. We talk about capital N is the population size. All right, little n is the sample size. Here's a notation in this book, and in general, it can be super confusing at times because it switches back and forth quite a bit. I mean, heck, even for sample means sometimes, admittingly, sometimes, and I'm not saying this happens all the time, but sometimes I've seen sample mean listed as U bar. So it's like, well, thanks for making it harder than it needs to be. But sometimes you'll see that for whatever reason because it's just written that way. And I'm like, okay, now you're just making it tougher for absolutely no reason, trying to make up new notation. And I'm like, well, let's just try and keep it as simple as possible. I strive in this class to keep it as simple as possible for you in terms of notation because it floats around like all over the place, admittingly. So if you do see this here, if you do see, I'll just put this down here. I'll put this to the right. If you do see this like U bar, then that's essentially sample mean. It's I don't know how to put it here. It's really weird. So no, it's a thing. It's a thing with notation in this textbook. It's a thing. I ain't gonna lie. So I'm just here to clear up any of the confusion that there may be. But that's why we cover it just like so. All right. Now we have that there. Okay. Okay, so now we have that there. We're all set and ready to go. It is, all right. Let's see. Technically. All right. Let me give you guys an option here. It is noontime, so we've been going on for about an hour. So, we usually take a break in between. Do you want to take a break, or we just have a little bit more to go here with the material, and then I was going to end off for the day. So, would you like me to keep going, or would you like to take a break? I will have you guys tell me in the chat which way would you like me to go. Since you guys. Okay. Okay. Again, if at any time that I feel that there's just a little bit more material to go, then I'm gonna always ask you because you guys had voted that you wanted to take a break. So if you guys say, hey, keep going, I'm gonna keep going. Okay. So I always listen to you guys. Your opinions are gonna be the ones I'll listen to, as I said from the first day moving forward. All right. So we'll go ahead and do just a little bit more here, and we'll talk about number 7, 8, and 9 here. So let's do number 9. Number 9 is where we are going to talk about how it relates to sample variance. We're going to talk about probably one of the most important things we'll talk about in this class, which is talking about standard deviation. And we'll talk about sample standard deviation and population standard deviation. Okay? I'm going to talk about both. So how do we find sample standard deviation / population standard deviation? First and foremost here, why is this the most important? Why is this one of the most important things here? Well, we're going to use this in a lot of different concepts, number one. Number two, what exactly is standard deviation? Well, standard deviation represents, in terms of a definition, represents how far away, on average, data items are from the mean. Okay? So how far away on average are data items away from the mean? That's going to be your standard deviation. Standard deviation is used in a lot, and I sincerely do mean a lot of statistics and a lot of practical applications on an everyday basis. So definitely a very important thing to do. But to understand standard deviation, let me explain standard deviation, and to understand how we can do standard deviation, let's take a look here at the formulas. Well, the formulas here are actually fairly simple. Why? Well, it all comes down to the notation. All that stuff I talked about in variance here, these guys, well, turns out it's going to be super useful. All right, let's talk about sample standard deviation first and foremost. Uh, Actually, let's do, yeah, we'll do sample standard deviation. All right. Why is sample standard deviation going to be important here in terms of its notation? Let's discuss it. What's the notation here for sample standard deviation? Well, turns out to be, let's see here. Let's take this. Notation here specifically is going to be, well, the notation here is S. Just the little letter S. All right, that's what it is. Just S. Okay, that's all it is. Now this S should look familiar because it's the same exact S that we had here from number 8 from our sample variance, which means that if we looked at the formula here specifically, all we would have to do here is take a good look here at oh, I actually do have to make a change there. Guys, do make one change here. Sorry, I did make one error here. I apologize about that. Do make one change with the sample variance in your notes. I'm going to make that change right now. I need you to put this over, this is actually very important. Put that over n minus 1, n minus 1. I forgot the n minus 1. This should still be capital N here, but that should be n minus 1. Apologies about that. That is actually pretty. But if I were to do the sample standard deviation here, then all I would need to do here is take the square root of that entire thing. Because remember, square root of s squared is just s. So that's exactly how I'm going to approach how I can find the formula here for s. Is exactly that. And everything is exactly the same, by the way. So, there you go. Easy peasy lemon squeezy. All right. Population standard deviation is pretty much the same thing. So we talk about population standard deviation. Then basically we follow the same pattern here. Again, if we go back to our guy for our variance, we can take a look at that. Again, the notation here, as you could probably guess, is just going to be that row. I'll put that up there in a sec. Go. Okay. Notation here. The notation here is going to be just row. All right. So that is population standard deviation and sample standard deviation as formulas. Again, just the square root of the variance. That's it. Because of their notation, we could just take directly. We could take directly the square root of each one here. Oh, why did it? Oh, darn it! Hang on. Jesus Christ, my fault. I'm such a dingus. All right. Gotta stop being dumb. I'm sorry. This should look like this. There we go. That should look like that. Why did I put the actual formula there? There we go. There we go. That's what it should look like here for sample variance. Jeez. All right. making a mockery of myself here. All right. There we go. All right, that's a lot better. So this is what it should look like for sample areas. S squared is equal to, without the square root, over n minus 1, and then with the square root should be sample standard deviation. Now, let me point out something here. I know there's like a lot of stuff kind of written down. Am I expecting you to memorize this? The answer is absolutely not, okay? So let's get that out of the way right away, all right? I'm not going to expect you to memorize this. What I would like you to do is to actually apply it to be able to find these respective answers. Okay? So let's get that out of the way. So that way, there's less of a massive piece of confusion that you may see here. Now, even though I've stated these formulas just like so, again, you can go through this by hand and actually find the standard deviation here, and that would be fine. So again, if we go back to our example here for just a moment, the thing that we would use the most here would be this 23.0714. All right, and we would take every single one of these data items. So let me just go ahead and show you here really briefly what we would do by hand if we were to do it. We would do 3 minus 23.0714. We would take whatever that is, we would square it, and then essentially we would add that to every single data item. So we would take 7 here minus 23.0714. We would quantity square that, and we would keep going down the line here. We would divide this by, in this case here, n minus 1. You get the general gist here after we add up all the guys together. So we take the sum of all these guys. I'll do ... here, and we would do 48 minus 23.0714. Quantity square it. Again, just following the formula that we have here, right? And then we would take that sum, whatever that sum is going to be. I don't know what that sum is going to be. We're going to take that sum, we'll divide it by n minus 1, which would be, in this case here, 14 minus 1, which would be 13. And then we take the square root of all that stuff to get our standard deviation. Now, admittingly, this would take a long time for us to do, and I'm not going to go through the painstaking process to do that. Normally, in my previous classes, I actually would show you by hand about how to do that here. But that's not really the big focus here for what we want to be doing. So, like I said, don't worry about this, but I just wanted to show you here just briefly how you would do it by hand. Literally, this is how you would go about doing so. All right. In any case, the more important thing is, how do we do this in a much faster format? Okay. So I want you to be able to look at these here carefully. So what I would like you to do now, everyone, everybody who's in chat here, there is something that I'm going to ask you all to do, is I would like you all to please take out your calculator. Make sure you have your graphing calculator with you. We are going to take out our graphing calculator here for this next example. Okay, so let's bust out our calculator here. In this case, okay. So please take out your calculator here. I'm going to go ahead and work with the calculator here for this example for today. Okay, let me shut that down. Okay, now I'm going to bring up the example here that we have with our stem and leaf plot. All right, so we have our stem and leaf plot here over to the right. That's what you can see. All right, and we also have, let me put that up slightly a bit, and we also have, again, our calculator over here to the left. Okay. So before we get started here, I would like everybody to type done in the chat if you have your calculator in front of you, so everybody's on the same page. Please type done in the chat if you have your graphing calculator in front of you. Just making sure everybody's on the same page before I start. So be sure you're able to find it. Okay. All right, so I'm going to move forward here, okay? And again, please follow along with me carefully as I go through these calculator functions. So I'm going to go one step at a time, okay? So I will go slow, I promise you that, okay? I'm going to go slow here. And we're going to be able to find the standard deviation here of this data set with the example that we started here at the very beginning of class. Okay, now the first thing that we are going to need to do here is we need to actually write in all these values here. All right, that's fine. We're going to use all these values here in our data set. Okay, that's fine. Important, Sarah, be sure to bring your calculator once you find it for the next class, okay? So, because again, a lot of the things that we do here in the class will revolve around using the functions on the calculator. So I'd like you to get comfortable with it now before it gets a little bit more complex. All right, so the first thing I would like you to do is go ahead and hit the stat key here on your calculator. So let's hit the stat key here on your calculator. All right, and you should see this menu here just like so. Now, the next thing I would like you to do is the first thing you see here is that you see the word edit. We want to get to our lists here in our calculator. So we're going to hit enter here on the one that's already highlighted, which says edit. And you should get to a screen that kind of looks similar to this. If you have now my calculator is like the super new, nice kind of calculator, so you may see like 5 lists. If you have the old school calculator, you may see 3 lists. Like I have my manual calculator here that's sitting in front of me, so I can show you here really quick. This is like a really super old calculator that's like 10 years old or so. So I'm going to be yeah, so again, on this, if I go and hit the stat key here, I have just 3 lists on my calculator. So again, one thing that I'm going to be doing here, just to let you guys know, is some of you may have an old school calculator, some of you may have a new school calculator. I will be going through the differences between both because there are slight differences, especially in terms of the software between an old school calculator and new school calculator. So I'll be doing a lot of things in detail when we're doing those calculator button presses, especially if you have older calculators. It's not going to tell you how to do everything or what to enter in necessarily. So I will be stating how to do that here, so that way you're not caught unawares. All right. Now, if you have numbers here, if you have the super old one, Joseph, hey, Joseph, look at mine. This is a super old one too. I have the same one here. And that is exactly why I go through both types. Okay? Because I understand some people got hand-me-downs or they got used ones, and I had to figure things out through the old school methods. So I'm here to help you with both, with people who have the new calculators and people who have the old calculators. So don't feel bad if you have an old one here. I always go through both. I always mention both here. I guarantee you, you'll know exactly what to do. I go through it step by step for you, okay? Okay? So it's just the same for me because I have both styles, the one on my computer and the one in my hand. All right, so how do we go ahead and move this next? Now, if you have numbers here in your calculator, so I'm not going to write in the numbers here, by the way. So if you have random numbers here in your calculator and you want to clear out the lists, well, if you have numbers in here, go ahead and highlight the list here. So just go ahead and scroll up and highlight the list. Hit the clear key, not the delete key. Do not hit the delete key, please, for the love that all is holy. Okay, do not hit the delete key. All right, do not hit the delete key. Hit the clear key. Okay, hit the clear key and hit enter, and that will clear out all the numbers in the list if there are numbers already in there. All right, if you hit the delete key, I'm going to be incredibly sad. All right, in many different ways. Then you'll have to do extra work for no reason. Okay. The next part here that we're going to do is under list number 1, L1, is we're going to put in all the numbers in our data set here. You have to hit the stats key there, Sarah. I don't know what it looks like on your online calculator, though. So this is for So the stats key here is right here, Sarah, right where my mouse is hovering. Again, the online calculator, I'm not so sure about that, about where it is on your specific application. So right by the arrows here, right where my mouse is hovering on screen. Okay. Well, what calculator do you have there, Sarah? You have an A3, a TI? It's right here, Sarah. You see where my mouse is? Look at the screen. Where's my mouse? That's where the stat key is, right here. Did you get it there, Sarah? Want to be sure that you did. Go back for a second. So you see this key, we're going to hit the stat key. And then you're going to get to this menu here, Sarah. And then you're going to go ahead and hit enter on edit. That very first option you see that pops up right away. Okay? Then you're going to get to this screen right here. Let me know if you got it, okay, Sarah? Did you get it, Sarah? Tell me yes or no if you got it. If you got to this screen. Want to be sure that everybody. I just want to be sure. I know I'm taking a little time here, but I want to be sure everybody's on the same page here because I don't want anybody to fall behind. You're good? Okay. All right. So underneath this list here, let's go ahead and enter in all the numbers in the data set. All right. Perfect. Nice. All right. So let's enter in all the numbers in the data set here. So 3, 7, 10, 12, 16, 17, 23, 25, 8, 9, 31, 34, 40, and 48. Okay. So these are the numbers that you should see here. Again, you're just going to enter them in manually. You're going to have to do some manual stuff, of course. But there we go. We got it. Simple enough. Easy peasy. All right. Once you guys have your data entered in, please go ahead and type in done in the chat once you have all your data entered in to your calculator. Yeah. All right. Yeah, I'm gonna, again, as you can see here, I'm going slow here on purpose for you guys. So, because I know this is kind of like the first foray into the calculator, so I'm gonna be taking my time here. Let's see, Sarah, did you get your data entered in there, Sarah? Anybody else having issues? Okay, there you go. Okay. Yeah, just follow along with me, Sarah. Just type in done if you got all the numbers in, okay? I just want to get a good clear readout from everyone. Just make sure everybody's, again, going together. You're on the same page here. All right. All right. Now that we have all the data entered in here. Now, one of the things that I like to do here is just understand the calculator is really picky about certain things. We haven't quite reached there yet, Vince. We're going. What is this count? Yeah, we're gonna find standard deviation here, but I'm actually gonna go through some several other things as well. Thank you, Jasmine. I know how frustrating it is to use a piece of machinery when you're not sure what to do, so I totally understand that. So one of the things that I like to do on the calculator is the calculator is a really picky piece of machinery. So because it's very picky, we want to be sure that we're not entering anything bad into the lists or anything like that. So one thing that I always do here, and it's a good habit to have, is to quit to the main screen here. So we're going to hit second and mode, and we're going to quit to the main screen here. Okay, so that way, what that ensures us to do is that making sure that we don't enter in any stray numbers or any other crazy things in the list. Okay, so again, just covering our tracks just in case. Now, after you get back to the main screen here, we're going to go ahead and hit the stat key here once again. I'm going to hit the stat key here once again and get back to the same place that we were before. However, instead of going to edit, because that's where our list is located, instead we're going to go over to the second menu here, which is the Calc menu. So this is where we should be in this instance. Okay. So we should have the Calc menu here, and this is the list that you see here. So before we move forward here, I want to be sure everybody got here. Please type done in the chat if you got here. No problem. Please type done in the chat once you got to this menu. That way everybody knows where they're at. Good stuff. Okay, Jasmine. So once again here, let me start from the main screen. Hit the stat key here, Jasmine. Okay, and then hit the right arrow to get to the Calc submenu there. Okay. Okay. Let me know if you got there or not, Jasmine. Okay, cool. Anybody else having issues? If anybody's having issues, please bring it to my attention now. So. Okay, let's go ahead and move forward here. Now, where are we going to find our standard deviation here for this particular data set? Okay, so now we have our data set here. We have it in our list. So I'm going to bring up this guy here for just a moment, for a particular reason. All right, so on the calculator here, we are going to be using that very first option you see there. Okay, so we're going to be using 1var stats. Okay, so that 1var stats that you see there at the very first option, number 1, we're going to hit enter right on that guy. Let's hit 1var stats there. Now, let me point out something here in this case. If you have the new school calculator, you're going to see this submenu that you have on my screen. If you have the old school calculator, it would be on your main screen, and on your main screen you would just see the words 1var stats. Let me describe what's going to be happening here. If you see this submenu here, what you want in that very first one here is list. It says list, okay? Now, this usually defaults, as you saw on my screen, to L1, which is list number 1. If you don't see anything there, or you have something different in that particular spot, what I would like you to do is you can go ahead and manually put in list number 1 here. You can, to manually put in list number 1, you hit the second key and the number 1 key, and that's going to be L1. So you want L1, which is list 1, where we put in the list of all our values in our data set in, just like so. If you have the submenu here, this is just for the people who have this submenu. This frequency list, you're going to leave that blank. Leave that alone. That's not going to be part of the process, so that's going to be left blank. And then you're going to want to go ahead and go down and hit calculate. All right, and so you're going to end up with this particular guy right here. Now, if you have the old school calculator is going to look like this. Let me show you what you have here. You're going to have something, you probably have something that looks like this, on your screen if you have the old school calculator, 1var stats. All you need to do from this point forward is you need to put in the list that you want to use and test over. So you're going to hit the second key and the number 1 key, which will be L1. Okay, and then you're going to go ahead and hit enter, and then you're going to get to the same place that the people with the new school calculator have as well. Okay, so again, 1var stats, second and 1 for list number 1, and then you should get to this screen right here. So these are the values that you should have. Absolutely, Sneaky Weasel, absolutely. Let's do that one more time. So for the old school calculator here, Sneaky Weasel, we'll go ahead and hit the stat key. We'll go over to Calc. We'll hit 1var stats. Now on your screen here, I know I have the sub menu here, but on your screen here, you're going to have just 1var stats. So it's gonna, let me do it this way. All right, I know this will be kind of a roundaboutish way, but it is what it is. So on your screen, this is what you see. When you hit 1var stats, you'll see just 1var stats on your main screen. I want you to go ahead, Sneaky Weasel, and hit the second key and the number 1 key for L1 and hit enter after that. And then this is what you should see next on your screen. All right, everybody who has this screen and has these values, please type done in the chat. So I want to make sure that everybody's on the same page here. I want to be sure everybody has this available, has these values. You're not seeing the same exact thing, okay? Like the same exact values, okay. So Jasmine, I would like you to go ahead and hit the stat key here, Jasmine. And then go to edit. Oh, you're good? Okay, never mind. All right. Thought maybe there's some values in the list. Okay, so that's what I was going to go do. All right, you're done? All right. Anybody else having issues before we move forward? Let me bring back my values here, sorry. Anybody else have questions or anything of the like? Okay, that's fine. Yeah, you just scroll down and see the rest of the list. All right, that's okay. Yeah, that can happen sometimes, so be sure you enter in all those numbers in correctly. Oh, okay. All right, now let's take a look here. Let's take a good look here. Is now we went ahead and did this on the calculator. I want you to take a good look here, all right? Because there are certain values that you see here on the screen that should look familiar to you. Let's take a gander. First of all, the very first one here. Hey, would you look at that? There's the mean, 23.0714. That's what we found out at the very beginning of class here today. Not such a bad thing. You know you did it right if you got that. Easy peasy lemon squeezy. All right. You can also scroll down here. You notice there's an arrow over here. You can hit the down arrow here. And you can find out MED, which represents the median here, which is 24. Hey, that's exactly what we found here as well. The median is 24. Wonderful. All right, so far so good. Now, if we scroll back up again, let's hit the up arrow here one more time. All right, let's take a good look here at two other particular values, which are probably the more important parts here of what we want to be looking at here and the question we want to answer. So if we want to talk about sample standard deviation, on the calculator here, sample standard deviation here is going to be this SX. So if you see this SX right here, this SX here represents the sample standard deviation. So the sample standard deviation here would be 12.9939. Okay. Remember, go out to 4 decimal places here. So the sample standard deviation, according to our calculator here, if we did it by hand, we would get the same exact answer. But we get 12.9939 would be our sample standard deviation. That's what this SX represents. Then we have this rho X here, which is the population standard deviation. All right. And so in this case here, we have 12.5212. Notice, again, it is a different number here because you're looking at it from two different perspectives. You first to say, is it a sample or is it the whole population? That's why there's a significant difference. Again, also another way you can tell there's a significant difference in the population standard deviation uses a straight up sample size, whereas the sample standard deviation takes that sample size and subtracts it by 1 at the end of the formula. So, okay, so the sample standard deviation 12.9939 and the population standard deviation here, which is 12.5212. All right. And that's how we can go ahead and find the standard deviations here via the calculator. Are there any questions about that? Do any of the other symbols matter? Well, glad you asked that, Vince. The answer is the other symbols like the Q1 and the N. Well, the N is the actual size of the sample or size of the population, which is 14. But these guys here, the again, sigma x represents adding up all the x's together. Sigma x squared represents, adding up all the, if you squared every data item and you squared it, that's what it would add up together. Now, as for the other guys that you see here on this one bar stats, like Q1, Q3, and the max, yes, those are actually going to matter, but we're going to be looking at that next week. When we're looking at the data set here. So we're going to be doing another example. We're not going to be doing the same example here, but yeah, those will actually matter here in a slightly different way. So I'll talk about those here in greater detail. So you'll get to find out about those. But a very valid question, yes. But today I wanted to take it slow here. I wanted to take it slow. I was going to try and get through 3.3, but that's okay. I'd rather go at the pace that you guys are comfortable with. And hopefully you get comfortable here, at least the beginning parts of using the calculator here, to getting some of the information that we're after here. Are there any other questions? Any other questions that we may have? Okay. All right. So, yeah, I'm not going to get to that today. Number 10 and 11, those are the next. So 10 and 11 we'll talk about here for next time, by the way. We'll just start with that, and we'll do section 3.3, and we'll also start with the latter half of chapter 3. But we're a little bit ahead here, so that shouldn't be too much of a problem here, in all honesty. So I think we're fine in terms of pace. So we're in really, really, really great shape. Just as a reminder, everybody, let me go to the big screen here. Just as a reminder here, everybody, we are, again, although we don't meet on Mondays, or we don't meet on Mondays, as a reminder for your other classes, if you do meet on Mondays, remember that Monday is Labor Day, so, again, you probably have the day off. Well, actually, you should have the day off, so, yeah, just as a friendly reminder, if you've forgotten like I did. Time flows together when you're always online, okay? All right. Does anybody have any other questions? Do you have any questions at all before we head out here for the weekend? Yeah. So, what sections would I like you to work on? That's a fair question. Yeah, sections definitely 3, 1, and 3, 2. So 3, 1, and 3, 2. Yeah. We'll finish up chapter 2. We did that last time, but 3, 1, 3, 2 is what we focused on here today, Jasmine. So. If you're going to keep a pace with what we're doing here, those are the next two sections on the docket. Alrighty. Well, yes. Let's do. All right. All right. Well, I want to thank everybody here for coming on out here to the stream once again. Thank you so very much, everybody. All of you are absolutely fantastic people. I, you know, I love you all. All of you are great. Okay, all of you are absolutely great. Thank you again. Um, Everybody, have yourself an absolutely wonderful weekend. And as always, everybody, again, you know where to find me. I'm on Discord. You can find me on email if you need to talk to me, if you need to ask me a question. Remember, if you sign up for my math lab, please get started with that homework. That homework's going to be due eventually, fairly soon. So, all right. In any case, stay safe, stay healthy. As always, stay safe, stay healthy, and most importantly, everybody, stay sane. All right. Have yourself a great weekend. Have an enjoyable long weekend. All right. And give yourself some time to relax, certainly. All right. We will see you all Tuesday, everyone. I love you. All right. Great job, everybody, today. All right. Thank you so very much. Take care of yourselves. All right. Everybody, take care. All right. Bye. Bye, everybody. Have a great one.